All right, so analytic metaphysics. I'm going to be talking today about more traditional metaphysical topics, some of which we've addressed in passing in the initial 3 sessions of this course, some of which I'm going to deal with in more detail today. So ontology is a strategy for creating consistent representations of what is going on in reality. And the kind of ontology which I have been working with since 2002 or thereabouts has always been very focused on empirical science. So the idea is that if we want to do ontology well, in other words, if we want to find a good, consistent way of describing reality, then it's science that we should look to as the basis for doing ontology. Nowadays, I also do ontology work for non-scientific efforts, for instance, relating to the military. But I always try and find a scientific counterpart to serve as the basis for building a good ontology. So the ontologies that I develop are always science-based or reality-based or evidence-based. However, when I say a good, consistent representation of reality, it's important that the representation of reality should involve a view of reality which will also satisfy human beings. And so I try to develop ontologies which are not merely consistent with science, but also consistent with common sense. And we'll see how that works very soon. But this summarizes why we need ontologies, because there are now many areas where multiple people using multiple techniques are developing huge bodies of data about the same things. And unless we have an ontology or something like an ontology, then we won't be able to integrate those data in order to make discoveries. Now, I've worked in developing these ontologies for biomedicine with a colleague of mine who is a Belgian neuropsychiatrist and now a professor of biomedical informatics in the division of biomedical ontology in the Department of Biomedical Informatics downtown in the Buffalo School of Medicine. This is, we think, the first academic unit with the name ontology in its title. His name is Keusters, C-E-U-S-T-E-R-S. And he likes to emphasize this approach to doing ontology. So there are entities in reality. The patient on the surgical table who is being treated by the doctor. And these entities in reality exist both in the level, both as instances, this particular patient, this particular doctor, this particular surgical instrument, and so on, and also at the level of universals. Patient, person, surgical instrument are all universals in the sense that there are many instances. So universals, another word is generals, general things rather than particular things. Then there are cognitive representations. Scientists have cognitive representations, doctors have cognitive representations, patients have cognitive representations of those things. So we represent to ourselves what it is to be a patient or what it is to be a surgical instrument. And then we have a cognitive representation of a certain universal. Or we represent to ourselves this particular patient or this particular surgical instrument, and then we have a cognitive representation in our heads of some particulars. But cognitive representations are in our heads. We can't communicate or compare them. To do scientific work, we need to make those cognitive representations publicly accessible. And to do this, we use language, or we use cartoons or diagrams or databases or files in a computer. So ontologies and scientific theories and patient records in a hospital computer are all level 3 entities. Now, level 1 entities include everything which exists, and so everything on level 2 and on level 3 is also a level 1 entity. And sometimes we actually do have cognitive representations of cognitive representations. In fact, if you're listening to me, then you're doing exactly that now. In fact, if you're listening to me properly, then you were just having cognitive representations of cognitive representations of cognitive representations. And if you were listening to me properly, then you would have cognitive representations to the 4th power. And if we continued this, you would have cognitive, we just did, you would have cognitive representations to the power of the 1st ordinal number, I guess. But anyway, we won't go in too much detail about infinitely complex cognitive representations. We can also have cognitive representations of publicly accessible concretizations of cognitive representations, and so on. All right, so these are the 3 levels. What is going on the side of the patient, the ideas in people's heads, which we can't know, although they themselves can know, and then the language which they speak, which, if you're lucky, they do understand. And this is another slide from Werner. So this is reality out here. This is external reality level 1. And then we build in our brains cognitive representations, and then we communicate with others about what is there. That's called doing science. All right, so science starts with level 2, carries out experiments, and results in level 3. Publications, data, textbooks, and so on. And this level 1, level 2, level 3 forms a methodology which we call ontological realism. So we first of all, some people anyway, do science. They then create ontologies adequate to what they've discovered. And that means basically they take the terminology used by the scientist and turn it into a term list, and then they give it some structure to turn it into an ontology. So the ontology is some kind of simplified representation of the world of the scientist. And then we turn it into a representation which will not be just a collection of terms, but which will be an organized representation of the relationships between the entities represented by those terms, both universals and particulars. Now, the important thing here is that we're representing the entities in the world. We're not representing the entities in our heads or the entities in our colleagues' heads. We're not trying to understand scientific concepts. We're trying to understand what scientific terms refer to in reality. And the reason why I emphasize this is because if you read literature on ontology, very often people will use the word concept, typically they will not think very clearly about what they mean by the word concept, which will mean that they will not be engaging in coherent exchange of ideas about ontology, because this word concept is so often used without clear understanding of what it means. And so I like to institute a rule whereby anyone who uses the word concept gives me $1. Now there are, so if I use the word concept, and I didn't use it, I just mentioned it, concept, and I give you all $1, which is a good deal if you think about it. I guess I should give you all $1 for the fact that the word concept appears on this slide, but this was written by Werner. So, all right. So, scientific ontologies are very much like scientific theories. I think of them as the terminological part of scientific theories. That's a good way of dealing with this. There are some distinctions which are important to make. So scientific theories are highly quantitative, often, where ontologies are primarily focused on the qualitative, taxonomical aspects of reality. But there are some ontologies which work well with quantitative information, and there are some ontologies which are ontologies of quantitative information. All right, now, if you're doing ontology in a scientific way, then you have to accept what it says here, that every term in your ontology is about something in reality. Now, you might say, well, why would anyone build an ontology which was not about something in reality? Well, there is a school of ontologists, in some ways the most important school of ontology in the entire history of modern applied ontology, which is based in Italy, led by a gentleman called Nicola Guarino, who is a friend of mine. And the view of Nicola Guarino is that ontologies should be strong enough to capture the ways people use language completely generally, not just scientific language, not just scientific language associated with the intention to refer to something in reality, but also language used when you're studying mythology, or when you're studying poetry, or when you're telling fairy stories to your children or to yourselves. That all such language is equally deserving of ontological representation, as is the language of science. I think that's just wrong. I think that the scientific approach to ontology does not allow you to build ontologies which refer to nothing at all. Now, there are no such things as unicorns, and so there should, and everyone in this room agrees with me that there is some important truth in the matter that there are no such things as unicorns. And so I hope that everyone in the room agrees with me that it would be a waste of time to try and build an ontology of unicorns. Now, there are people who say that they believe in unicorns. They have unicorn psychiatric issues. And they are real people and they have real psychiatric issues. But we should be able to describe everything that we need to describe about such people without having an ontology of unicorns. All right, but we can have ontologies about information artifacts, such as videos of people who think they believe in unicorns, about experiments with people who think they believe in unicorns, even about organizations of people who think they believe in unicorns. All of those things exist. All right, so we've already seen this central division between universals and instances. We don't need to go further into that. Ontologies are about the universals in reality, primarily. So the ontology will consist of a hierarchically organized representation of general entities. I call them universals. Some people call them kinds or types or categories, species, genera, and so forth. That's what ontologies are about. Now, each one of those kinds or types will have instances. And so the ontology is, in a secondary sense, also about those instances. But in a primary sense, it's about the generals which those instances instantiate. And that's why all the terms in ontologies are general terms. So consider an inventory. An inventory is about generals. It's about all the kinds of things that you find in a warehouse. I got that. So a catalogue is about generals. This is a catalogue down here. Tells you the kinds of things in your warehouse. The inventory is about how many of each of those kinds of things you have. In other words, it's about instances. So ontologies are like catalogues. A good ontology it includes as part a catalogue of the entities in its domain. An inventory is like a database. It tells you how many of that particular kind you have for each kind. All right, now these are all universals, and these, for instance, are all the extensions of some of these universals in a particular factory. By an extension, I mean the class of instances. Yep.
Can I say that ontology is a representation of what instance? Because if an instance doesn't have, that doesn't make sense to have an universal.
Okay, so are there junk instances which do not fall under any universal? Now, the top level of an ontology might be something like entity. And anything which exists is going to be an entity. And so there's always at least one universal. It's a very boring kind of universal. But there is always at least one. So from that point of view, there are no junk instances. But of course, there might be instances of particular things. For instance, a paper water bottle remote control device supporting configuration. Actually, I should mention the desk also, of which there might be only one instance in the universe at this moment. I think that, so there are two reasons to build ontologies. One reason to build ontologies is the kind of reason which interests philosophers. We want to have a good metaphysical representation of, for instance, what exists. And I think BFO is a good representation, measured in some ways. It's certainly the most popular metaphysical representation of what exists today. The other reason is because you have specific needs for data integration in medicine or in some other domain. Now, if there was a specific need for a term for this kind of configuration, that presumably is because there are many, many instances of it. And so I would be quite happy to say that there would then be a universal. So this is not a universal. It was created, it's a fake example. But if it became important because there were many instances of it, then it would be, in my view, acceptable to regard it as a universal and to include it in an ontology. All right, so here we have universals. Each universal has an extension, which is the collection of its instances, or the class of its instances, or the set of its instances. We have an issue with time. Do we mean the collection of particulars at some time, or do we mean the collection of particulars throughout the entire history of the universe? That may become important later on, but for the moment we don't need to worry about that issue. So this is the aggregate or the totality of all the objects which are instances of the universal A at some time t. All right, so for scientific ontologies, we're interested in the generals, we're interested in generalizations. When we're building databases, then we need to keep track of patient number one, and we need to keep track of patient number one's headache, and so on. So databases are for instances. Ontologies are for cataloging the universals. This is a fragment of a very important medical ontology which is designed to represent human anatomy. And this is the top level of the ontology. So we have two kinds of anatomical entity: anatomical structures, such as organs, and anatomical spaces, such as organ cavities. And an example of an organ is a serous sac. And the plural sac is a special kind of serous sac, which is a special kind of organ, which is a special kind of anatomical structure. So the solid arrows here mean is a special kind of, or is a sub-kind of, or in ontological speak, just is a. So similarly, the interlobar recess is a serous sac cavity subdivision. And along the dotted line axis, we have part relations. So the interlobar recess is a part of the pleural cavity, which is a part of the pleural sac. Another part of the pleural sac is the wall of the sac, otherwise called the pleura. and the visceral pleura is a part of the pleura, and the mesothelium of the pleura is a part of the visceral pleura, and so on. So this is a very well constructed ontology about a very, very complicated but very stable collection of universals which we all instantiate. We all instantiate nearly all of these universals, and some of us instantiate all of them. So if you've had your pleural sac removed, then you wouldn't instantiate this particular corner of the ontology. But typically, ideally, every human being looks exactly like this. Except the whole ontology is, I don't know, very, very large. Now, I said that the general terms representing universals form a catalogue with a hierarchical structure. This is an example. It's not a very good example for all kinds of reasons, but so we have instances down here. They're all instances of this kind, frog, which every frog is an animal, every animal is an organism, and every organism is an object. Now, you can't take photographs of universals. No objections. But you can create cartoons. This is a cartoon of the universals in the, which are the primary constituent parts of every instance of the universal cell, or human cell. Now there is a question. We talked earlier on about the paper, water bottle, remote control supporter configuration. Is that really a universal? And I said, well, if lots of people build them and they use them for specific purposes, then that would, in my view, be sufficient for them to count as a universal. Similarly, there is a universal Ford Pinto, I think. There is a universal Ford Fiesta, and there is a universal Ford Fiesta Mark 23 model 461. So all of those are, to my mind, perfectly acceptable as universals. But is there a universal friend of Neil? I mean, there are many friends of Neil, but does that mean that there is such a universal? I think not. Is there a universal person standing exactly 100 miles away from a friend of Neil? I am sure not. There are, I assume, conceivably anyway, many people who are standing exactly 100 miles away from a friend of Neil at any given time. But I still don't think it's a universal. So we have a continuum. We have clear cases. Person is a universal. Table is a universal. We have slightly less clear cases. Ford Pinto is a universal. We have problematic cases. Friend of Neil. And then we have obvious non-cases, which you can easily make up just by stringing nonsense words together. Now, some people say that this is a problem for the ontological approach to supporting science. If we don't have a clear algorithm or a clear device which we can use to test candidate terms, general terms, to see whether they are representing universals, then the whole approach must fail. I think that's wrong. So we don't have a clear test or algorithm or device for working out which sentences are true. There are some clear cases of true sentences. We are alive, for instance. This is a table. Neil exists and has two eyes. And then there are some clear cases of non-truths. So Neil is a cardinal number. This table is made of green cheese. I am an even larger cardinal number. All of these are false. And then we have cases in the middle. Trump will win the election, which we don't know whether they're true or false. And that's not a problem. Just because we have a penumbrum of cases where we can't decide for different kinds of reasons doesn't mean that the idea of truth has to be abandoned. And similarly, just because there is a penumbra of cases where it's not clear whether a given term refers to a universal, that doesn't mean that we should abandon the goal of trying to represent universals by building ontologies. So here is so these are some clear examples of non-universals. These are some clear examples of universals, and then problem cases in the middle. Now, as I say, there is no algorithm. So what do we rely on? Well, for all of these cases, we rely on the best current science. The best current science isn't clear about whether there is such a universal as dark matter. Maybe they have made discoveries since I created this slide. But they are all clear about the fact that these things exist. And you would never dare to ask a scientist about whether those things represent universals, because they obviously don't. So that's the first rule. To find out whether a term represents a universal, you should see whether it's a term used by scientists. Scientists sometimes use terms to carry out experiments. So they may ask questions to people about whether they believe in that Elvis is still alive, for instance. And then they may classify their patients into Elvis believers and Elvis non-believers. That doesn't mean that Elvis believer is a universal, but it's moving Elvis believer at least into this box. But that still doesn't make brother of Elvis fan a universal. And I can't imagine, although who knows, that there will ever be an experiment to test some feature of brothers of Elvis fans. Now, another issue is that scientists make mistakes. So, phlogiston was once held by scientists to be a general term with a good scientific referent. But now all scientists realize that the theory of phlogiston did not turn out to be true. All we can do is rely on the best current scientific evidence, but we have to realize that the best current scientific evidence may turn out to be wrong. So everything we do when building applied ontologies like this is carried out under the assumption that it may be that in X years' time we'll turn out that we made a mistake. So the name of the ontology that I referred to earlier, the human anatomy ontology, is the foundational model of anatomy. And it's called a canonical ontology because it's about the ideal human being, which means the human being which our genetic makeup programs for. We are programmed to build a plural wall of Stack. That's the instruction for building a plural wall of Stack is already in the fertilized egg at the very beginning. And the program for building 32 teeth is also built into the DNA of the fertilized ovum from the very beginning. Now, statistically, human beings do not have 32 teeth. They have, I think, males have 29.2, and females who get into fights less often have 29.6 on average. And it varies depending on which part of town you're in. But canonically, we all have 32 teeth. And that's what the foundational model of anatomy is about. And that is a general principle for building ontologies. The first ontology you build should be an ontology of the canonical case in your domain. So if you want to build an ontology of cars, you will build an ontology of the car which runs off the assembly line and is completely new, not subject to any missing parts or damaged parts. And then you will build an ontology of damage. But you build a canonical ontology first, because that's the only way in which you can capture what you want to capture within a reasonable time. Because there are so many different ways of damaging a car, but there's only one way of being the assembly line model that has all the parts in it in their original pristine form. Now, the canonical human anatomy is about the assembly line human being. We're all pretty much, everyone in this room at least, even him, is an assembly line human being. All right. So BFO we've already seen. BFO takes the approach that the universals in reality can be divided into two kinds. It does claim to be complete in the following sense. If somebody can give me a universal which is not either here or here, and convince me and the other people who manage the BFO content that we can't represent that universal, but that the universal is needed to do science today, then we would add a third alternative. So BFO wants to be able to represent all the universals which are important for science. And at the moment, we are able, just with these three, so independent continuous, dependent continuous, and occurrence. Of course, we have various subtypes, but just with these three basic building blocks, we claim to be able to capture all the universals that science needs. And what that means is that they all appear underneath one or other of these three root nodes. Now, I already know that there are some problems, and I'll just give you one example of a problem. Patterns. So if you have a Morse code message, you can either write the Morse code message on a piece of paper, or you can create a series of sounds. Now, what you write on the piece of paper and what you create as a process are the same pattern, we might say. But one is a dependent continuant, it's a pattern of ink, and the other is a process, it's a pattern of sound. Now, BFO says these are disjoint from each other, they don't overlap. And we need a way of dealing with patterns. The pattern problem is completely general because all language can exist either as speech or as writing. And writing is continuance, speech is occurrence. Now we have, I will talk a little bit about some aspects of this later on, but we have not yet found that this is a great difficulty. So it's an issue, but it's not a great difficulty. The BFO approach to understanding how universals are organized seems still to work. All right, now, the ontological realist approach says we're only interested in reality, we're not interested in unicorns because we don't want to waste our time. We're only interested in those entities which the best established science will acknowledge as existing. Now, the opposite view, I'm calling it here Midas touch epistemology. I will explain what that means in a minute. The opposite view says what exists is not something which is objective, which can be gauged by looking at what the best scientists believe in, but rather it's something which is subjective. And scientists believe in one subjective collection of entities. They have one subjective worldview. People who believe in unicorns or in witches or in evil spirits have another subjective worldview. And there are many subjective worldviews, and no one of these subjective worldviews is better or worse than any other. And the Midas touch epistemology says there is some kind of reality out there, but we can't know what it is. And science is just one way of creating a fake representation, and there are other ways in which we create fake representations, or we tell conceptual stories. That's a quote. I'm not. We can never ever get outside our conceptual stories. And there is a really beautiful paper called "The Worst Argument in the World." This is about the paper, and I strongly recommend that you read it. That particular link will take you to the paper about the paper and also to the paper itself. So the worst argument in the world goes something like this. We can never know what reality, so we can only know what reality is by using our organs, our sense organs. Because we can only know what reality is by using our sense organs, we can't really know what reality is in itself. We can only know reality insofar as it conforms to the structure of our sense organs. And therefore, we can only know what reality is as it conforms to some subjective feature of our epistemological apparatus. So we create reality. That's Midas touch epistemology. By seeing it or hearing it or smelling it, we create the reality which we can experience, and we can only know about that created reality. Now, there are many versions of this Midas touch epistemology. One version is linguistic. It says, we can only know about those things which we can describe in language. Therefore, we can only know about reality insofar as it conforms to the structures of our language. Therefore, we can't know about reality in itself. Now, one of Stowe's arguments against the worst argument in the world goes like this. We can only eat oysters by using our mouth and our digestive organs. Therefore, we can't eat oysters as they are in themselves. We can only eat oysters insofar as they conform to our digestive organs. And therefore, there are two kinds of oysters, basically. The ones that exist in reality, which we can never know, and the ones that are conformant to our digestive organs, which are the ones that we eat. And we can never compare whether the ones that we eat are the same as the ones which are existing in reality, because we can only know the ones that conform to our digestive organs. Now, this is, I think, an obvious argument against Midas touch epistemology generally, but if you don't believe me, then read this, and you will believe me. All right, so Midas touch epistemology takes many forms in contemporary philosophy, so all forms of postmodernism and so on. So French things that they are subtypes of Midas touch epistemology, or there's something even worse. All right, so the alternative is ontological realism. Another example of the world's worst argument would be people who wear spectacles can never know what reality is really like. They can only know what reality is like insofar as it conforms to the lens structure of their spectacle. And since if they take their spectacles off, they can't see very much at all, then they can certainly never know what reality is like without their spectacles. Now, this is, of course, to misunderstand why people wear spectacles. People wear spectacles because they want to have a better transparent lens rather than just use the one that's in their eyes. The two, okay. So there are lenses which are transparent, and that is the basis of ontological realism. We build telescopes, we build microscopes, we create spectacles, we create all kinds of devices for doing scientific measurements because we want a better way of learning what reality is like, rather than because we want, for some strange reason, to put some non-transparent filter between ourselves and reality. So reality exists behind a transparent grid. This is the fundamental idea which I mentioned already of a transparent partition. So there are many transparent partitions of reality, and ontologies are indeed a kind of transparent partition if they are built correctly. They are ways of viewing reality through the terms which represent the universals in the corresponding part of reality. So this is the way I like to conceive of an ontology. It's a way of viewing reality which is transparent. Now, I said earlier, I want the ontologies to be both scientifically adequate and also conforming to common sense. And the idea is that common sense, too, is a transparent partition, or a transparent way of grasping reality. So the reason why we all share the same common sense, according to which Neil exists, Neil has 2 eyes, Neil has 1 nose, just checking. That's all common sense, and we all share this same common sense. Because if we didn't, we'd be long dead. If any of our ancestors had held that some obvious truth of common sense was false, they would be dead. They would not have survived the evolutionary forces of nature, and so they wouldn't have had children, and so we wouldn't be here. We are here because all our ancestors, at least a long way back, shared the same basic commonsensical worldview. So common sense is true to that degree. This is Anachronistus. So I'm not going to answer. I guess I should switch it off. And then there are indeed sub-disciplines of common sense: folk physics, folk psychology, folk biology, and so on. And I did my very first works on this kind of view of common sense were about folk physics and folk psychology and folk biology. And I still hold that this is the correct approach. So, the fundamental thesis of ontological realism is that many of both our commonsensical and our scientific partitions are transparent to reality. So, BFO deals with all branches of reality. Folk psychology deals with the psychological branches of reality, as does scientific psychology. Folk psychology uses a relatively coarse-grained partition. Scientific psychology uses also, or tries to use, relatively fine-grained partitions. We have ontologies to deal with the folk psychological partitions, including the emotion ontology. Emotions are a subtype of BFO process. They exist in reality. So ideas, thoughts, beliefs, emotions, and so on, all of which are level 2 entities, they exist in reality, and we can have ontologies of them because they are part of level 1, just like every other level 2 and level 3 entity is part of level 1. All right, so level 3 is about information artifacts, documents, databases, legal constitutions, boarding passes, railway tickets, contracts, and so forth. And BFO has a way of dealing with such information artifacts, and we have now the information artifact ontology, which attempts to produce an ontology of the realm of level 3 entities. Now, I said that an ontology should deal with universals, and the universals should be such that they would be believed in by the best contemporary scientists. Another criterion, which may be redundant, is that they should have instances. Now, unicorn loses for 2 reasons. First of all, scientists don't believe in unicorns, and secondly, there are no instances of unicorn. But average salary is an example of a term which is used by scientists, but which should not be included in an ontology because there are no instances of average salary. That's why we talk about average salaries, because we don't want to collect data about the instances. We want to have a proxy for the data about the instances, which is data which we call average salary data. But then average salary data is what really exists, and that's created by a mathematical process. But there's nothing which the average salary data is about, which we could call average salary, as if that was a special extra entity. So And this is how we deal with friend of Neil. So there is a class of all friends of Neil, just as there is a class of all persons who flew on a plane with Bill Clinton. But that's not an extra entity. It's not a universal. It's just an aggregate of persons. All right, so we have universals, we have their extensions, and we have what are called defined classes. Person who was cleansed in the waters of the Ganges, person who flew to Mecca with Neil, and so on. These are all defined classes. They're not universals. Yes?
So how about like dinosaurs? Dinosaurs have...
Yes, so the collection of universals which exists, and I have to be very careful about tense here. So there is a collection of universals which have instances now. There is a much larger collection of universals which have instances now or had instances in the past. Science deals with all of those universals. Some scientists also claim to deal with the universals which will exist in the future, but that's not established science, that's speculative science. There could be some established science which does succeed in predicting universals, if you like. But I don't know of any good examples of established science which does that. But there's certainly a lot of established science about universals which existed in the past. Those universals did have instances, and so that is good enough for the universals themselves to be included in the family of universals. Yes?
This is a question about realism. It's something, sort of case that I'm worried about. So I'm worried about a case where scientific theory will tell us whether the thing is real or exists, and yet the thing, we might be able to be certain that something doesn't exist, but an ontology might still want to treat it. So I'm thinking of an example I know Neil's familiar with, you should be familiar with too, is numerous countries claim that they have ownership of the South China Sea.
Yep.
So they can draw their own maps for,
Yeah.
this is how much I own or whatever, right? No scientific theory is going to tell us which one is real. The ontology still will want to be able to, maybe this isn't a problem at the level of universals, but there is data about the countries that claim ownership of the South China Sea.
Yeah, I think that the BFO way of dealing with such cases would be to recognize that there is a universal ownership claim or territorial ownership claim. There is the instance, which is the particular contested spot on the planet. And then you have two countries and their governments, and each government has a claim on this spot. And everything which I just referred to exists. And I think that by referring to those kinds of things, you can say everything that you need about those kinds of instances.
But you do have information about, so there might be some fact of the matter about which country owns it or something.
Yeah.
You can have a lot of information that either fails to refer or refers to things that don't exist, like China's ownership of...
Okay, so...
And then it seems like the reference is to a non-existent...
Good, so we have...
No reference.
Okay, so it's Japan and China, let's say. Japan and China both have claims to ownership of island X. Let's suppose that it is true that China has a justified claim, that China really does own island X. I think that there are such justified claims which are genuine ownership relations. So there are two claims, one genuine ownership relation. And then there is this other thing which stands between Japan and this island, which is just a claim. Now, what am I missing? You seem to think...
So Japan has a claim, and that claim is about, in some way, it's about Japan's ownership.
Okay, good. So,
right? So
Japanese dreamers think that there is a Japanese ownership relation with X. And in order to do justice to the state of mind of Japanese revanchists, or whatever we call them, then we have to accept that there is some relation of ownership between Japan and X, which has this lesser status than China's ownership of X.
Well, all I'm saying is we want to be able to talk about it. We want to be able to refer to it without.
That's why we have the word claim, sure.
Well, what the claim is a claim. I mean, so say that the claim comes in some sort of document or something, right? It'll be about Japan's ownership of this island. And I think we want to be able to talk about that, but not necessarily implying that this ownership really exists in the social world.
Yeah. So I think that this is actually a genuine problem for the BFO approach. So BFO says that we should accept something into an ontology only if that something is accepted by established science. What we're dealing with here is not science, it's political, international relations. There is no settled science of the instance level international relations in the South China Sea. There are disputes. And BFO is, the ontological realist approach is just not very good at dealing in those areas where there is no settled science. We would have the same issue 10 years ago with the Higgs boson. In fact, we did have it, because we were saying we shouldn't put Higgs boson into an ontology of physical particles because it's not settled science that the Higgs boson exists. And the physicists in the room were saying, but physicists need to use the Higgs boson to formulate their hypotheses, and therefore you have to put Higgs boson into your ontology. And my answer to them was, what you do in your own private life is your own affair. If you want to create an ontology with Higgs bosons in it, because that's the way you do speculative physics today, then you can do that to your heart's content, and I will be happy. And then in 10 years' time, you can come back and you can add the relevant ontology bits to the established science physics. Now, I'm thinking that there may be a similar solution to the South China Sea territorial problem. I don't see it quite so clearly, but I think that's the way I would have to go. Yeah.
So a similar problem I'm running up against is with possibilities. So thinking about representing
that is
possibilities.
Another issue.
Have you had any thoughts about how to represent possibilities?
Yeah, don't use possible worlds.
Okay.
So the way I would like to go is this. So some people talk about unicorns. They are obviously making a mistake. Other people talk about possibilities, and sometimes they do that, and it's obvious that they're not making a mistake. One area where that happens is planning. But do you have other good examples of areas where that happens, other than planning?
In possibilities?
Yeah. Where we
Planning's
talk...
pretty good.
But do you have some other area? Because I can do planning.
Well, it's going to come up in this game theory stuff that I'm working on. So if you're plotting out the likelihoods attached to different possibilities.
Okay, so anticipating the future.
Yeah.
So...
There's retrospective, like counts of responsibility. What could they have done? Right? Legal responsibility. This person had the option to avoid breaking the law.
Okay, so I'll do planning first, and then I'll try and do those two cases without any promises. So planning goes like this. If there is real discussion, so by real I mean discussion which is not just language going on holiday, which I think what is happening with the unicorn case. So we don't want to deal with those cases where language goes on holiday. When you're doing planning and you're talking about future possibilities and where language is not going on holiday, what are you talking about? You're talking about certain ways in which you or your team or your family or whatever it might be are gearing up to go on the trip to Florida or to invade Pakistan or to do whatever it is that your plan is about. And then the really existing thing is the dispositions which you create in yourself. That's real. Because that disposition exists, certain other things acquire dispositions. So the hotel where you booked into has the disposition to accept you as having a reservation there. So you start to be able to think about the world in the light of the fact that dispositions exist in the present, really now, and they exist not just where you are, but also where you will be when those dispositions are realized. So talk about possibilities is talk about dispositions which actually exist. When you're doing planning in a real sense. Now, if you're just daydreaming about one day I will own 3 Ferraris, one red, one white, one blue, then that's not planning, and you're just daydreaming. That's unicorn land. All right, now anticipating the future, I think, if it's not language going on holiday, is planning. So you are anticipating a nuclear war, and so you start to put silver paper in your cellar on the walls and so on. So I think I can deal with real anticipations of the future, and not just daydreaming in the same way. And now, retrospective thinking about possibilities. I don't like doing philosophy like that. I'll just, maybe it's because the same reason I don't like dealing with possible world. So we want to understand why it is that John had legal responsibility when he shot Mary while cleaning his gun. And the reason why he had legal responsibility is because he could have cleaned his gun more carefully and thereby avoided shooting Mary. Is that the kind of thing that they say in the... Yes?
Yeah, I mean,
What's a standard example?
So I'm thinking of cases of excuses, right? People are entitled to certain legal excuses if they couldn't have taken a reasonable course of action that avoided breaking the law, right? They were being coerced, they were in some sort of psychological state that impaired their ability to choose.
Okay, so John was cleaning his gun, John was testing his gun by firing it at this test thing. And without him knowing it, Mary crept behind the test thing and put herself in the line of fire. So whatever he did, there is no possible course of events which John could reasonably have been expected to perform, which would have saved Mary's life. Now that... So in order to see that, you do indeed have to think about alternative possibilities. And so...
I mean, it doesn't have to be strictly possibilities, that real possibilities. It could be, well, could I imagine him...
Yeah, I know. So... All right, so these are... when we speculate in this way, and this will actually be the topic of the lecture, perhaps even next week, about how we deal with information artifacts which are not true. So let's suppose that the way to do this is you go through the 6 scenarios which would have involved John doing reasonably expected things in order to ensure safety while firing at the range. You go through, you have 6 alternatives. One would be that he never turned away from the firing range, but then there were fences on either side, so he could, even if he focused constantly at the firing range, he still wouldn't have seen Mary because she's only 3 years old, she's too low, and so on. So we think about 6 alternatives. Now each of those alternatives is about Mary, it's about the firing range. So all of these things are things which exist in BFO terms. It's about Mary walking, it's about Mary making noise. She was very quiet. Mary was well known as a quiet baby. And each of those sentences is false. So they're about Mary, but they're false. And in a week's time, if we're lucky, that depends on whether I finish today's lecture on time, we will talk about how we deal with falsehood. Now, this is not the unicorn kind of a falsehood, which is where there is nothing you're talking about. This is about the Mary walking behind the screen kind of falsehood, where there is something that you're talking about, but you're saying something false about it. And so my argument for the scenario you described would be, in order to establish innocence or lack of culpability of John, you have to demonstrate that he was not negligent. Him being negligent would involve either this or this or this or this sentence being true. These sentences are about Mary and so on, but they're all false, and therefore he's not culpable. Now, the idea that each of these sentences describes an alternative possible world or something like that is obviously just ontological sugar. So I rest my case. That's my answer to your challenge. I'm not very proud of it, but yep.
So
is this about this? Because he was.
no, it's not.
Okay, you go next.
Yeah, I'm curious about average salary. So you don't want this. This is not a universal.
Yeah.
That makes sense.
And that's because universals must have instances.
Yeah. So I'm curious, and I suspect I know what you'll say, but what about mean molecular motion, center of mass, these types of physics quantities? Probably don't have instances. They're super useful.
Center of mass, which I understand, I think does have instances. I think you have a center of mass, I have a center of mass. I think that's different from...
I'm not sure.
Yeah, at any given time, I think we have a unique center of mass.
Okay.
Now, the mean molecular
motion.
That sounds to me more like average man. Although this is something which has worried me a lot. We talk a lot about qualities in BFO land. Temperature is always at one example that we use of a quality, but it may very well be that temperature is typically some averaging function, the result of some averaging function, and that therefore we should use another example instead of temperature. Doctors use temperature a lot, but then we use the average man or the average height a lot. So these things are useful, but that doesn't mean that they exist.
Sure.
On the other hand, we want to be commonsensical. So if we go around saying things like there is no such thing as temperature, then that would be a mistake too. So
that makes less sense than saying there's no such average salary.
Yeah.
It seems common.
So temperature is something which I'm uncomfortable about. Yep.
So, two quick questions. One about the average salary. I can imagine some cases where accidentally there's something that instantiates something like average salary. In that case, we would have a universal instantiated by a salary which exists, and it is the average salary.
No, I think that let's suppose that John earns exactly the average salary. It still wouldn't be the case that John earns that thing which people call the average salary. John earns his salary, which is a determinate amount. It doesn't depend on other salaries that other people earn. It's just an absolute number of dollars or whatever it might be. Where the average salary, even though at any given time it has a certain value for a certain reference class, is not that value. It's that value within a certain information context.
Yeah, sure.
So I don't think that's a counterexample.
And so are social sciences excluded by the range of hard science that...
No, social science is a big challenge for BFO. I think that social sciences that have some working parts, so there is some fraction of social science which is established science. It's not in the best of health at the moment, but there are still some parts which are established, and we want BFO to be able to deal with those parts. In fact, that's one very active area where we're trying to extend the reach of BFO by analyzing social entities.
So in that case, maybe we would deal with many non-existent objects.
For instance,
in history,
say again.
In history, we have many cases where human beings have been influenced by something that we cannot say that exists.
Give me your best example.
I would say Zeus.
Zeus. So, well, this is just Zeus is just unicorn.
Yeah.
So the people, so many people believed in unicorns for a long time. Many people believed in Zeus for a long time. We can give accounts of their beliefs without giving credence to the existence of the putative object of their belief.
So in that ontology, we would include just the belief, not of course.
Well, we'd have to include all the churches and temples and the documents and footprints in the stone and so forth. Everything which is associated with the beliefs, which exists. There are many such things.
Even if it would be like more stuff to put in.
I think that an adequate account of the social history of Z believers is going to be simpler if you don't assume that there is a Zeus than if you do. Because what people believed about Zeus varied from generation to generation and from community to community wildly. And so if you assume that there is a Zeus which is serving as the object about which all those beliefs were conceived, then you make more problems for yourself than if you just study the beliefs. Yep.
I'm instantiating a bunch of universals. I presume Neil is as well. We both exist. Is there a singleton which we both share in common? Is there a universal singleton set? The set of John, the set of Neil. These are they have something in common.
So I take seriously the idea that universals can have indefinitely many instances. Now, it could be that there is a universal which, for accidental reasons, only has one instance. Although it's hard to think of a good example. But in general, it's safe to assume that they have indefinitely many instances. And that they can always have new instances. Even dinosaurs.
Sure. I have an unrelated
Yeah.
question to that. Is there are there any instances of irrational numbers?
So I said that BFO wants to deal with all of those entities which are accepted as existing by established science. Now, I think that mathematics is not part of established science for these purposes. Not because it's not established, but because it's not science. It's not about entities which are discovered through experimentation or observation. It's about entities which have a different role. Now, I am constantly being asked to include numbers in BFO, and I constantly resist, because it seems to me that BFO does not need all the issues of the philosophy of mathematics on its table. B, because we don't need an ontology of numbers. There's no unless we are mistaking the purpose of numbers in, for instance, formulating data. They're not extra entities. They're ways of describing the entities that we have.
So capturing the practicing mathematician in their work, this would just be like a domain level extension.
I can't imagine why we would want to capture the mathematicians at work. I don't see any interesting scientific questions which hang on data about that. I can see
proof methods that themselves might be used to construct better.
Okay, good. That's yeah. So you might do a kind of scientific history of mathematics, which is interested in the evolution of certain methods of proof. You want to know who was the first mathematician to. And then you would need a term like method of proof. I would accept the term method of proof, and I think BFO could deal with method of proof. Yep.
So this is a question about the Midas touch epistemology. it seems like we're, even within scientific contexts, we're pretty rife with things and entities and aspects of entities that are not discernible to human physiology, infrared, or pick any number of things.
Yeah.
How it seems like they're like not a huge leap to make like a Kantian move that maybe humans are physiologically, constructed in such a way. Maybe constructed might be a weird word, but physiologically made up in such a way as to understand reality in a certain way. They include things like space and time and what have you. And maybe there are fundamental aspects of reality which are outside space and time, or what have you.
All right. So I think that we use science in order to test for those kinds of subjective or one-sided or partial aspects of the human way of understanding things. So we do go outside common sense. We do go outside the visible spectrum. Where I would draw the line would be in saying, well, maybe there are things which exist which are completely outside the scope of science as we could ever perform it. And that seems to me to be a bad kind of thought experiment. That doesn't mean that philosophers of importance haven't used it, but I still think it's a bad kind of thought experiment.
Okay.
And it's bad because you're wasting valuable ontology time. Yep.
So in your teaching, you said average salary is not universal. It doesn't have instance.
Yep.
So for many statistical variables like average, variance, 95% confident interval. So they should belong to dependent entity BFO.
So we are just building an ontology. It's called the Ontology for Biological and Clinical Statistics. In that ontology, we provide, and this is connected with your question about mathematical proofs. So statisticians deal with certain entities, and those entities include things like methods of calculating averages and means and so forth. And we built the ontology to deal with those statistical methods, outputs of statistical methods. The output of a statistical method for generating the average height of a group of people is going to be an information artifact of a certain sort. And that we do allow information artifacts, but it's not an average height, which would have instances which are, and it's hard to see what the instance would be. It's an information artifact which has instances which is your calculation of the average height for this population, my calculation of the average height for that population. So each of those would be a number, 73 feet, maybe not so tall, 70 feet, and you would get 69 feet and so on. Oh, I have a tall people are. I don't know. You get the difference?
So should it belong to dependent entity?
So it's an information artifact, which is a dependent entity. We'll come to information artifacts later on. It's a generically dependent entity. And it's information, where a height is not information. His height is a real quality of him, and my height is a real quality of me. And height quality is a universal which has at least two instances. If you do a calculation, somebody gives you the heights of all the people in this room, and they do a statistical calculation to calculate the average height of the people in this room, the answer will be 5'10". Is that better? That is not some special entity called the average height. It's a value, 5'10", which is, in a certain context, the average height of the people in that room is 5'10" inches. So I think I'm still in good shape, even with statisticians. All right, so if we go back to this, so there is a certain structure here, and the structure includes this. Now this is a rather simple kind of partition. This is a more complicated partition. And examples of this partition would be, well, an example that would go hand in hand with the actual Alberti grid would be where the things in the cells that you see when you look through the grid are actual physical parts of the reality. So this is the Beatles partition, which you whenever you look at the world through Beatles focused spectacles is what you see, even though John is dead. That's what you see when you think in the world in the Beatles way. And if you're thinking of the world in the periodic table way, then you see that, although you see a lot more of it on either side. And if you're thinking of quarks, then you think in that sort of way. So these are all partitions of reality which capture a certain domain of reality at a certain level of granularity. And the point about BFO is that it's supposed to be compatible with all such partitions to the extent that those partitions are veridical. In other words, to the extent that there is something which is visible when you look through the corresponding grid. Now, these are all qualitative partitions. Even here, we're dealing with a qualitative difference between different kinds of atom elements. This is a quantitative partition. So when we measure somebody's temperature at different points in time, we're always using a certain coarse-grained view because we don't have exact instruments for measuring temperature. We always have to use whatever is the valid legal decimal place number for our particular purposes and for our particular measuring device. So we would record John's temperature in something like this way. All of these are, I have to be very careful here. So this is John's temperature. We measure it at T1 and we get this result. The result is an instance down here of the universal temperature of 37 degrees Celsius. And that universal is a sub-universal of the universal temperature. So this is sometimes called a determinate universal, and this is a determinable universal. Determinate universals are very specific. Determinable universals are generic. So John's temperature varies through time, goes through different values, as we say, but each one of those values is still an instance of the same quality temperature as all the others. Yep.
I guess this seems strange to me because then it sounds like 37 Celsius is an instance of temperature. But we could have measured this in Fahrenheit too. Why not say that the 37 Celsius is the output of a measurement of a universal rather than an instance of a universal?
Because we are looking at John's temperature through a Celsius grid. Someone looking through John, looking at, so the real thing which is common here is down here. Someone who's looking at John's temperature through a Fahrenheit grid at exactly the same time would see the same temperature instance, but through a different partition. Now the partition is of the same reality, and the partition is giving you views of John's temperature, so it's the quality which is the same. Now the quality is cashed out on the level of John in a continuum. And we can slice this continuum in a coarse grain. We'd say John's temperature is warm. That would also be correct for a certain band. So we're using a very coarse grain partition if we talk about warm, hot, normal, cold, very cold. Or we could use just 37 and then switch to 38 whenever it goes beyond 37.5. So there are different partitions, and there is no way of doing a screen which contains a continuum of temperature, specific temperatures. Now, so you have a laptop. Your laptop is 18 inches or so across some dimension, and it's also 30 centimeters. Now, which one is right? Both are right. Your temperature doesn't have two lengths, but it has two length measurements. Now, when I represent those length measurements, I'm representing something which exists independently of whether we measure it, and even independently of whether we have Celsius. But we do have Celsius, and so I use that fact in order to create a slide. We could represent another, well, I probably have one somewhere, a slide showing 37 degrees Celsius as the output of a measurement, but then it's not 37 degrees Celsius temperature, it's 37 degrees Celsius as an information artifact, which is the output of a temperature measuring process, which is something quite different. I can't help it. We have to use partitions. There's no way of seeing something's temperature, just as there's no way of seeing something's length without using a measuring device. So your laptop has a certain determinate length, even if we have no way of measuring it. But you tell me what it is, without using a system of units.
So maybe I'm misunderstanding. So the 37 Celsius here is just a marker for the temperature instance. Is it just a label?
So it's complicated because of the lack of precision in our measuring instrument, but I can simplify. Let's suppose that we have a perfect measuring instrument, but it's only perfect when it hits a one decimal place value. So between those gaps, it just doesn't give any reading. So at T1 it gives this reading, at T2 it gives this reading. Then this reading is, this box here represents the universal temperature of what we, using the Celsius partition, call 37 degrees Celsius. That's an exact temperature value. Anyone who has that temperature value will get the reading 37 degrees Celsius. And so we could call this anything we like. We could call it the temperature that Neil had at exactly 4 o'clock on Wednesday. But then we presuppose exact clocks. So we can't get around the problem of exact measurement so easily. But if we could do the exact measurement, then we wouldn't need the Celsius. We could just use ostension. Anyone who has the same temperature as this person at T1 has what in Celsius would be called exactly 37 degrees Celsius. But that's a temperature. It's not a reading. It's just we have to use the crutch, the prosthesis called Celsius. Yeah?
The example seems to how to instantiate of the particular's temperature. Well, suppose when we think about the collection of the particulars, how can we instantiate of the temperature of collections?
So, in other words, you have a large collection of individuals and you're taking the temperature of all of them?
Yeah.
So why is that a problem? Why can't we just have, we have this diagram for John, we have another diagram for Fred, another diagram for Jim, and so on. It's just more data. So I don't see the problem.
When we think about the thermostat to keep the temperature for the heating, we need to just think about like everyone's the temperature and the average temperature or things like that. So.
Okay, so if we have a thermostat, then the thermostat is going to be taking the temperature of the air in its immediate vicinity. Now, I agree that there is a problem. There is some averaging going on. It's even clearer than in the case of taking the temperature of a human being. But I already confessed that I have problems with averaging temperatures in any case. So everything I said about this slide, you should think of it as being about a different example, not temperature. It's about height. Height. There's no problem with height. Yeah?
I do understand these sub-universals represented in specific number, but how about that represented in a range? Like from 37?
Yeah, I think it's just the same. I think these are ranges. So if we have cold, normal, and warm, then it would just be exactly the same structure. Because there are gaps between these two. What if you have 37.05 degrees Celsius? Then there's something here which is vague. And similarly, between warm and normal, there's some vague division. And you can't represent those vague divisions precisely because they're vague. But I have a slide which shows that. Maybe it's it's not the next slide. So this is the partition, and then this is the slide. So here we have ranges rather than quantitative values. And here we have this. There are no sharp boundaries between the embryo and the fetus. Some of these boundaries may be fiat boundaries, which means we just decide arbitrarily to say, well, the embryo is at the end of 8 weeks, is it? All right, so, and diseases, we can do diseases also. So John's coronary heart disease starts with CHD in the phase of early lesions and ends with stable angina and goes through various different phases on the way. And we can do it with organs developing in the embryo and fetus. So the heart in this case. Or with tumors, which are not captured within the foundational model of anatomy because tumors are not canonical anatomy. So these are more pictures of tumors. Now, I'm introducing the tumors because we have another problem which we need to just talk about briefly. So I didn't go into any detail about this as yet, but metaphysical views in the Anglo-Saxophone world of recent years have been divided into two big families. On the one side, we have what are called four-dimensionalists. And four-dimensionalists believe that there are only processes. Everything is a four-dimensional process. So there is no Bill Clinton. There is just a process which is a Bill Clintonizing process. And there is no Washington. There is just a process which is the Washington, D.C.izing process. And during a certain period of time, the Buffalo Clintonizing process was a part of the Washington, D.C.izing process. And you can work out for anything that you like, which you think is a thing rather than a process, how you would rewrite the history of that thing in such a way that only processes would be in your metaphysics. Now, four-dimensionalism is not the majority view amongst contemporary metaphysicians, but it is the sexy view. It's the view that gets you most points for being brave and so. On the other hand, there is the three-dimensionalist view, and in a very strong form of three-dimensionalism, there would be no processes at all. There would just be things which exist in time and of which certain predicates hold at certain times. So now I have the predicate is in Buffalo holds of me, and has Buffalo in it holds a buffalo. Sorry, has me in it holds a buffalo at this time, and then tomorrow it may be that Dayton, Ohio has me in it. So there are just things, just three-dimensional continuant entities. And there are no four-dimensional entities at all. There are just predicates which hold of things at various times. Now, those two schools of thought have really impressive arguments against the other school. So there is a perfectly coherent story of everything which can be told in 3D terms, which has certain advantages. And then there is a perfectly coherent story which can be told in 4D terms, which also has certain advantages. And the 3Dists can point to the advantages of their view, and the 4Dists can point to the advantages of their view. And Maureen Donnelly is an expert on those kinds of disputes. Now, BFO was designed to be irenic, that is to say, to be a happy compromise. between 3Deism and 4Deism. So we want to be able to say things like this and to take seriously that this part refers to a process, a 25-year-long tumor development process, and these parts of this sentence refer to objects, things, 3D entities. So we think, and this is how BFO was born, actually. It was born in order to try and do justice to simple medical sentences like this, which involve, like very many sentences, references to both processes and things. So that's why BFO has continuance and occurrence. They are both first-class entities within their ontology, where three-dimensionalists would try and reduce all talk about occurrence to talk about continuance, and four-dimensionalists would try and reduce all talk about objects to talk about occurrence. All right, so we want to put these things together. And now we have a question. So we have the process development. And we have the question, well, this is a process, so it has to have participants. And so you say, what is it that participates in this process? And you can't say the tumor, because there is very little which the tumor, when it first is recognized, has in common with the tumor after 250 days. And there is even less if you look at the tumor as it was forming before it was recognized, which this is just a molecular disturbance of some kind, which this thing over here has in common with the tumor after 250 days. So this seems to be a problem. We can't use the word tumor and have it refer to something, because what it refers to at the very earliest stages and what it refers to at the very late stages seems to be completely different. And if this is a tumor in the lung, which develops so radically that there's hardly anything left of the lung as it originally existed before it was invaded by the tumor, then the lung too is going to be such that it refers to something which seems to be quite different at the first pre-tumor stage and at the late tumor stage. So this is a problem, and the problem has to do with the lack of determinateness of parts. So, and this is one argument why people become four-dimensionalists. So a three-dimensionalist would say, well, Neil exists, and Neil is a three-dimensional entity. Then what is Neil? He used to be one cell, according to some views of these matters anyway. And that one cell looks very different from this creature. Yeah. So this is a problem. This is why to embrace the idea of ironic compromise between four-dimensionalism and three-dimensionalism is not easy, because we want these three-dimensional things to exist, but it turns out that it's not easy to believe in three-dimensional things when you want to make clinically coherent statements be represented in an ontologically coherent way. All right, so the idea is that just gluing things and processes together creates problems. And that this is why some people deny that there are objects, and why they are four-dimensional, and why other people deny that there are processes, because they prefer to use a view according to which there are things of which predicates hold at different times, and that is already a solution to the ontological issues that we face. All right, so that's an object and that's a process. This is a really old slide, which I should delete. All right, so how does BFO deal with this problem? Now the answer is BFO really does believe in three-dimensional entities, which means that it really does believe that Neil was once a single cell. It is the same entity which is now this creature before us here, which used to be a single cell. But if we want to state anything about Neil, particularly about his parts, but also about his temperature or his height or any other qualities, we always have to give a time index, which is what the three-dimensionalists actually were insisting upon. That predicate, they would express this in linguistic terms. We would express it in ontological terms because we believe in qualities. But what we say is that if X is part of Y, where X and Y are continuants, objects, then we always have to give a time index. X is part of Y at T. Now for processes, you don't have to give a time index. If the first half of the match is a part of the whole match, then it's a part of the whole match atemporally. It's just a fact of the matter that the first half is a part of the whole. Because in the world of processes, part-whole relations, and qualities, any kinds of assertions hold atemporally. So the world of four-dimensionalism is very different from this point of view, from the world of three-dimensionalism. All right, so we saw this. So we have not just objects or things, we also have dependent continuants, which are things like roles. And for them too, it's important that you always make statements with a temporal index. So John has the role of being a nurse, not atemporally, but at a certain time, for a certain interval of time during which he was employed as a nurse by a hospital. And the same goes for dispositions and even for functions. So let's move forward. So these are some examples of quality. Well, these are some examples of dependent continuance. So whiteness of cheese, role as a lecturer, disposition to experience diarrhea. And now this is a more specific example of quality. So we are observing flies. As we're biologists, we're observing fly phenotypes. Some flies have red eyes. So we observe the color red in the eye of a fly. But it's not the eye which is red, even though that's what we say customarily. It's the color quality of the eye which is red. And so the correct representation looks like this. There is a particular instance of redness in this particular fly's, or of this particular fly's eye, which instantiates the universal red. And then there is an instance of eye in this particular fly, which instantiates the universal eye. And then the redness is a kind of color, and the eye is a kind of anatomical structure. And so we need this in order to account for what it is that you see when you detect redness in the eye of a fly. And that's the way the Pareto phenotype ontology is structured to do justice to that. So, I don't think I'm going to go... Well, yes, I probably should say this. So, we had on that diagram, eye is an anatomical structure, and we had this eye in this fly is an instance of eye. Now, what this means is that there are different kinds of binary relations. If we say human is a mammal, that's or eye is an anatomical structure, that's a relation between universals. So this means is a sub-universal of. But if we say this eye is an instance of the universal eye, and that's a relation between an instance and a universal. So this human is an instance of the universal human. We can also have allergic to. So this human is allergic to the universal penicillin. That's also a relationship between an instance and a universal. And then finally, we can have relations between instances. For instance, this eye is part of this fly, or this heart is part of this lady, and so on. Or this aorta is connected to this heart. So it's important to keep those kinds of relations separate because they have different logical properties. And And in the relation ontology that we built, we had three kinds of relations according to what I just described. And this is the original set of relations in the relation ontology. And this is how we define the relations between those different kinds of relations. So to say that A is a B, where A and B are universals, we define that in terms of instances. A is a B means all instances of A are instances of B. That's not rocket science. But notice that the relations between universals presuppose the instance level relation. To say that universal A is part of the universal B, for instance, human heart, part of universal human being, is to say that every instance of A is an instance level part of some instance of B. So this is the all sum rule. It would be better if it was grammatical, but here. So the part of relation between universals presupposes the instance level part of relation. And this is one way in which the ontology world of universals is connected to the ontology world of instances, namely the relations between the universals are defined by going through the instances. But this works, of course, only if you go through canonical instances. Because it's not true that every human heart is part of some human. There are human hearts which are waiting to be transplanted and which are neither in the donor human nor in the recipient human. And there are human hearts which have been taken out of humans for other purposes. So only for canonical humans is it the case that, and for canonical human hearts is it the case that every instance of the former is a part of some instance of the latter. And so that's, again, what the foundational model of anatomy was getting at. All right, so we've talked a lot about dispositions already in earlier sessions. Functions are good dispositions in a precise sense. So the function of the screwdriver is to transmit torque to the head of a screw in such a way as to screw or unscrew the screw. Now, what that is something about the physics of the screwdriver. It can do that because it is physically a certain shape, and because screws have been created to be a complementary physical shape. So dispositions are dependent upon physical makeup. Dispositions are internally grounded, realizable entities. Now, functions have to be not just internally grounded, in other words, based on the physics of the entity. They also have to be the reason why that entity came into existence. Now, the reason why the screwdriver exists is because somebody wanted a device for transmitting torque to the head of a screw. That's why they built screwdrivers. Now, the heart has a function, which is to pump blood. The reason why the heart exists, why we still have hearts, is because of that function. If our ancestors had not had hearts, we would not be here. So our heart exists because it performed this particular job in the bodies of our ancestors to enable us to come into existence. So functions are dispositions which are designed for, either by a designer, an engineer, or a manufacturer of some useful item, or by evolution. And if you go through examples of functions, then I think you will find that nearly all the examples fit with this definition. So it works for tools, it works for laptops, it works for hearts and lungs and so forth. And if you can think of something which we would say has a function, then that doesn't fit with either of those two kinds of cases, then that might be a problem for BFO. So this would be your big chance to identify a problem. All right, now each function is associated with certain characteristic process shapes. So remember, processes are four-dimensional, and so their shapes occupy space-time. And this is the four-dimensional process shape that goes hand in hand with the realization of the function of the heart to pump blood, as you can see with all the blood coming out of the and then the idea is that a canonical heart will create a good instance of this shape, where a sick heart will create a less good instance. Now, diseases are bad dispositions. If you have a disease, that's because, in the simplest case, some organ in your body is not realizing its function, or is not realizing its function well or adequately. And it's a disposition because it's a disposition to, for instance, symptoms or to chemical changes in your body which have harmful effects. And every function is associated with some functioning process universal. So every universal function is associated with the corresponding functioning universal. So the function to pump of the heart is associated with the process universal of pumping, which is what realizes the pump function. All right, now the next item we need to take care of is information artifacts. So all of the dependent continuants that we've talked about so far are specifically dependent. So my heart has its function, your heart has its function. That two functions are very similar, but mine is mine and yours is yours. Your temperature is your temperature, my temperature is my temperature. We can't exchange temperatures or borrow each other's temperature. So these things cannot migrate from one bearer to another. Now, we know that information artifacts can migrate. I can copy a PDF file from your laptop and have it be a PDF file, exactly the same PDF file on my laptop. So, but still, I can't have a PDF file unless I have some device in which the PDF file is stored. So PDF files are dependent entities, but they're not specifically dependent, they are generically dependent. And there is another kind of generically dependent entity, which is a DNA sequence. So we know that sequences can migrate because that's how biology works. Sequences can be perfectly copied, just as PDF files can be perfectly copied. So there are two main types of generically dependent continuants that we've so far dealt with in BFO. One of them are information objects, such as contracts or dollar bills. The dollars, let's say, not bills. Bills are just pieces of paper. And the other are sequences. Chemical sequences generally are able to be copied. All right, so, and then there are other examples, algorithms, scores, molecular structures more generally, poems, all of these things are information objects, or generically dependent continuants. And when you write a plan, and then you share the plan with your team members, then you're creating a generically dependent continuum which they can all realize together by creating each his own personal plan in his brain. And that's from Tolstoy's War and Peace, as you can see. And that's an information artifact. It's a generically dependent continuant. Beethoven's Ninth Symphony is a generically dependent continuant which is concretized in each score, and conceivably also in other kinds of media. Now, generically dependent continuants may be able to be concretized in multiple kinds of media, in paper or in neurons in your head. So if you read a poem, then the poem is there on the paper, but it's also concretized in some way in your head. And this is the pattern problem. So the neurons in your head are not static. When you read the poem, you're not creating a static pattern which would be isomorphic to the pattern of ink marks on the page. Even the ink marks are not completely static. But still, it's clear that there is something in common between the pattern which is created in your brain when you read the poem and the pattern which is the poem itself. All right, so serial numbers, social security numbers, email addresses are all examples of information artifacts which are dealt with in the information artifact ontology. And now, what this tells us is that we have to be very careful when we're dealing with instances and universals in the realm of information artifacts. So this human being here is an instance of the kind human being. Now, when we create an information entity, such as Tolstoy's War and Peace, then we create, first of all, a manuscript, and then publishers create multiple copies of the novel. Each one of those multiple copies is an instance. So we have many instances of War and Peace. And so you might think that War and Peace is a universal. But War and Peace is not a universal. War and Peace is an instance of another universal, namely the universal novel. So we have the universal novel, which has an instance, War and Peace. Another instance would be The Hound of the Baskervilles. And I'm sure that there is a third novel out there that I could dredge up. If Far From the Madding Crowd would be another novel. And then there are multiple copies of each one of those novels, which are instances of the universal copy of a novel. But War and Peace is an instance. It was created by Tolstoy through an incredibly complex, not quite random concatenation of Cyrillic letters, and which didn't exist the day before, but which now is able to serve as the starting point for copying processes like gene sequences. And just as the gene sequence is an instance and not a universal, so Tolstoy's War and Peace is an instance and not a universal, even though it can have many copies. And the test, whether something is an instance or a universal, is whether you can use it in the plural. So tables is a universal because tables make sense. You can count tables. Wars and Peaces does not make sense. The American Constitutions does not make sense. Hamlets does not make sense. Hounds, well, you can't do it with Hound of the Baskervilles. Anyway, that wouldn't even work syntactically. So the key, whether it's a universal, is whether it can be pluralized. Now this has to be, as a rule of thumb, this works very well, but it only works for camp nouns. So it doesn't work for luggage, it doesn't work for sugar, it doesn't work for information. These are all mass nouns. They don't have any plurals anyway. Discourse is a mass noun, which only has a plural in French, which should warn you against using the word discourse. But there's no fine for using the word discourse. There is a fine if you use it in the plural, unless you're French. So, War and Peace is not a universal. War and Peace is an instance of a different universal. And similarly with the Declaration of Independence, there are many copies of the Declaration of Independence, but there's only one Declaration of Independence. If there's only one of a thing, it's an instance, it's not a universal. Good. So, generically dependent continuants get concretized in specifically dependent continuums. So I write a plan, and then I read it, and I say, this is a good plan, I'm going to realize it, and then I make a plan in my head, which is a specifically dependent continuum of me, which is what guides my actions then when I'm cooking breakfast. And similarly in music, so Beethoven's Ninth Symphony is a generically dependent continuum. It's an instance of the kind symphony. It's also an instance of the kind musical work, because a symphony is a musical work. Symphony is a universal, musical work is a universal. The first is a subkind of the second. The Ninth Symphony is concretized in a specifically dependent continuous pattern of ink marks in a score. And that's a specifically dependent continuum because it's in this score here on this table. And another pattern is on this score on that table, even though the scores are copies of the same score from the same printing press, which are mark for mark identical. Now we can use that score, which we are holding in our hands, as a set of instructions for creating a performance, which is an instance of another universal, the universal symphony performance, which is a sub-universal of the universal performance, and so on. So this is the score. The score is an instance of generically dependent continuum. It specifies how to create a performance. The orchestra takes the score into the concert hall. The orchestra members are sitting in their chairs on the stage. They all have their own subscores for their own instruments. They are plan specifications for their actions in the concert hall. So the conductor has one big plan. The instrumentalists have their own little plans. The conductor's big plan is related appropriately to the small plans of all the participants. It forms a network of subplans, and each subplan is a disposition. And remember, dispositions are realizable, so they get realized in processes, and those processes are called performances. And then you're in the audience, you hear that process, and you copy, in some sense, the performance in your head. And that's where it gets neurological. So I'm not competent to discuss what happens once it's inside your head. All right. Now the next item we need to deal with are spatial regions. So you've got everything in BFO here apart from regions, spatial regions, temporal regions, and spatio-temporal regions. That we also need to do some work on the types of independent continuum. But this is the beef of BFO. This is the O of BFO. So your mouth is also, when it's open, has the same ontological structure as the cave. Leaving aside the fact that there is a tract, which is a rear exit or entryway into your mouth. But this is a simple cave, and there is a fiat boundary at the entrance to the cave, and then there is a physical boundary around the side. But if you examine the physical boundary very carefully, you'll see that it too is made of molecules, and that there is no point at which the cave ends and the physical structuring retainer begins, if you look closely enough. And so even here we have fiat boundaries. And so BFO now has a zero-dimensional fiat boundary, which would be the end of a line, or at the North Pole actually is a good example of a zero-dimensional fiat boundary. A one-dimensional fiat boundary, this would be the equator. And a two-dimensional fiat boundary, this would be the fiat boundary which is created at the entrance to the cave, and then and also at the wall of the cave. So the boundary of the wall of the cave is a two-dimensional boundary, but with a curvature in three-dimensional space. So this is a fiat boundary which is created by a cognitive act, or it's the kind of thing which could be created by a cognitive act, involving use of words like entrance to a cave. And this is the kind of fiat boundary which tracks a physical discontinuity. So we have qualities, we have realizable entities, we have independent continuants, and we have material entities which are divided as here, which I'll deal with in a minute. And then we have immaterial entities which include fiat boundaries which are either 0, 1, or 2-dimensional. Now, the other kind of immaterial entity we have is a site. So this room is a site. The cave is a site. Buffalo, as a place where you can live, is a site. It's a large collection of streets and entryways and parks and so forth, all of which are sites and which you sum together and you create Buffalo as a place where people live. Now there is another Buffalo, which is a collection of physical stuff, buildings, roads, traffic signs, blades of grass, walls, fences, and so forth. So the word Buffalo is ambiguous as between the physical infrastructure, including all the buildings, and the site which that physical infrastructure makes possible. Just as cave is ambiguous as between the site, which is the interior of the cave, and the physical structure in virtue of which that interior actually exists. Now, once the bear gets inside the cave, then we have a double hole structure. So a fiat object is a hole with an H. It's a place that that organisms can live in. So that's why this room is a fiat object. Why his mouth especially. He was yawning just now. His mouth is a fiat object in which organisms can live. And as soon as an organism lives in a fiat object, then you get a double hole structure because the organism creates a hole inside a hole, but he fills the hole completely. So I talked about Buffalo, but actually it's true of Manhattan too. Manhattan is ambiguous as between the material collection of bricks and rock and the complex site, which is the place where people actually live and move about, and cockroaches. All of this applies to caves, mouths, nostrils, your car, the interior of an aeroplane, that's a site. The interior of your bed. So your bed is a physical object with bedding, which is a physical object. But when you get into the bed, you create a hole which you then simultaneously fill, nearly. Unless you have a vacuum sealing bed, when you would fill it exactly. And this is the basis for the environment ontology. So sites are things like oceans and deserts and your gut, which is a very rich site for organisms. And then there are the material entities which live in those sites, and then there are the environmental systems which exist because material entities such as organisms exchange fluids with other organisms in the sites. And then the term ocean is ambiguous as between a site where fish can live and a collection of water. We define system and ecosystem and so forth, if anyone is interested in that kind of thing. And biome and habitat and niche. All of those are sites. So site is where life goes on. Now, some people worry about the difference between a site and a three-dimensional spatial region because BFO has both sites and regions. And the difference is that a site can move. A spatial region is tied to the relevant frame of reference. But a site may be the hold of a ship, or it may be your mouth. The interior of your mouth moves every time you move. Where your site moves through three-dimensional spatial regions. Your mouth moves through three-dimensional spatial regions when you move, so sites can move. And Maureen Donnelly also has a very nice paper on this phenomenon called relative places. So a site is a relative place. It's a place relative to a material entity which sustains it. So in BFO we focus on fiat boundaries and sites. So every continuum fiat boundary occupies a corresponding spatial region, and sites occupy three-dimensional spatial regions. So that's there. And material entities also occupy three-dimensional spatial regions. So material entities go hand in hand with sites. Every material entity which has its own boundary is almost certainly going to be in some site, for instance, so that it can breathe or swim or do whatever it does in order to stay in existence. All right, now we also have process boundaries. So these are all the occurrence in BFO. Processes, process boundaries, temporal regions, and spatial temporal regions. Process boundaries occupy zero-dimensional temporal regions. Processes occupy one-dimensional temporal regions. In other words, they take time. Process boundaries are beginnings and endings, or thresholds. And now we get to material entity, and I will do this very quickly, and then we'll stop for questions. So we've seen the three kinds of immaterial independent continuum: spatial regions, continuum fiat boundaries, and sites. And the interesting ones are material entities: objects, fiat object parts, and object aggregates. Fiat object parts are just your upper torso, or your nose, or your head, or the left-hand side of this table. I mean, this everything north of here. So fiat object parts come free. If you have the object, you have all its fiat object parts. So they're not problematic at all. Object aggregates are just sums of objects and nothing else. So that's an object aggregate made of a bottle and a remote control device. So there is an object aggregate made of exactly the people in this room now. And that object aggregate will disappear when we all leave the room. It will just cease to exist. So there are no problems about fiat object parts and object aggregates, I hope. So the problems all have to do with object. And this is an area where BFO is not claiming completeness. So there could be other kinds of objects. So molecules may be a good example. Atoms may be another good example. But we distinguish three kinds of objects. And basically, the underlying idea is that objects are natural units of matter. So they are building blocks or bricks. A brick is a good example of an object. Or they're organisms. Or they are devices, artifacts, robots, spaceships. Planets would be an example here. So we have organisms and organism-like units such as cells, portions of solid matter such as bricks, planets, and engineered artifacts such as watches or cars or railway carriages or screwdrivers or screws or chairs or tables or coffee cups or laptops or pens or cell phones or bottles of water or boxes of tissues or shoes. And that's it. So if you're all happy with that, then we can go home. So this is where all the action is, because this is where human beings are. We are all objects. Yep.
I have a quick question. Why there is no the three-dimensional fiat boundary? Because if you thought of this classroom, that we have we can define the boundary with this kind of x and y and
but
height.
It's always two-dimensional. So the walls are two-dimensional. The boundary, the surface of the wall is two-dimensional. The surface of the floor is two-dimensional. The surface of the ceiling is two-dimensional. If you add all of those together, they are extended in 3 dimensions. So you're right. But they are still surfaces. So what they bound is the site. So what you're looking for in the realm of 3-dimensional fiat boundary thingies is the site. And so you're right. The intuition is right. There should be something 3-dimensional. And there is. It's called a site. Yep.
I have a question about, you briefly talked about the process profiles and zero temporal regions.
That's next week. I was going to do that this week.
Okay, I can ask that next
Good.
week. Then I have another question about object aggregates. Do object aggregates specifically depend on their members?
No, because they're not independent. They're not dependent continuous. They are independent continuous.
Yeah.
So they have the members as parts. Exactly, the members as parts. They're the only parts they have, and that even goes so far as to say that the parts of the members are not parts of the aggregate. Although I don't want to say that in public. Yeah.
This may be a too elaborate question in the end, maybe, but so you said earlier that that technically we can actually map a science that is wrong.
Yep.
Ontologically speaking. But isn't there also some mechanisms in basic formal ontology that set certain rules that actually verify if our science is right?
It would be nice if there were, but unfortunately the BFO is not so sophisticated. So the reason why BFO can capture false science, I think, so you could have a perfectly good BFO representation of phlogiston, is because even scientists are human beings, and human beings are constrained by common sense in the kinds of creations or discoveries that they formulate as scientific theories. We're reaching the borders of that kind of constraint when we deal with quantum mechanics.
Yeah.
There is a lot in quantum mechanics which seems to be not commonsensical. But mostly science is still constrained by common sense. And so most scientists, including phlogiston scientists, were doing science which is consistent with BFO. So BFO has very little in the way of teeth when it comes to capturing error.
It seems that, so when you're dealing with, for example, some of the things I'm working with now with mental diseases, for example, people want to, take some pseudo bundle of symptoms and say there's a disease in some way, right? It seems like basic formal ontologists say that, no, wait a minute, you're jumping over some elements in the hierarchy, right? You need first a disorder, a physiological disorder, and then you have some disorder.
So BFO's view of disease allows that you could have diseases without ever having symptoms. And it's so that we do not take a symptom-focused view of disease. In other words, symptoms are the manifestation of the disposition, but it's the disposition which is the disease.
So would that be a verification?
So I guess it would be there is bad science, and then there is bad science politics. Now there is science politics in the field of mental disorders, which I think is unfortunate. And I think that BFO would be tending to push people away from bad science politics. But it doesn't have very much teeth. It would. So that's precisely the kind of area where arguments are going on between the kinds of people who defend a BFO approach and people who are symptom focused when it comes to disease. Yeah.
About the definition of universal as two universals are the same if they are the same instances, right?
Well, I didn't say that.
Okay. So it wasn't this definition of...
No, so I think it is almost certainly going to end up being true, but I didn't say it. Universals are not defined by their extensions.
Okay.
Relations between universals are defined by the fact that corresponding relations hold at the instance level.
Okay.
But that does not imply that every two universals has exactly the same instance.
Because of course I was thinking
Sorry.
about the kind of counterexample of animal chordates and renates.
Yep. So my view about chordates and renates is, first of all, it turns out that those words were made up by Quine. So there is no universal chordate or renate. It's an obvious philosopher's example.
So BFO wouldn't take this you wouldn't consider them as universals because scientists do not use them.
Yeah, exactly.
Okay.
Yep.
So I'm just curious, how do you handle the problem of coinciding object or material coincidence.
So BFO is a non-multiplicativist ontology. So there are those people like Lynn Rudder-Baker and Nicola Guarino, who from the leader of this Italian ontology movement, who are duplicativists or excessivists. I don't know what a good word for them would be. So they see you as being a human body and a person, and there are two of you. So there is the human body and the person coincide, but they're not the same. Where I would say you are just one thing. You are a human body, which is also a person. And BFO similarly tries to be a non-multiplicativist ontology. Now, there's a problem for BFO. Supposing that you form with Neil a string duet. The string trios. What's the two? Well, anyway, three of you form a string trio. But you also form a chess club, a three-cornered chess. Now, the parts of the string trio and the parts of the chess club are the same. And so if you are a non-multiplicativist, then you should say that the string trio and the chess club are the same, which sounds counterintuitive. And so BFO deals with that by saying that an organization like a string trio is an object aggregate in which each member has a specific role. And so the roles are first-class entities, and your role as a member of the string trio is different from your role as a member of the chess club. And so that's why we can still be non-multiplicativist. Now, if you are, I think I've said it now. That's my answer to that question. So we solve the problem of apparent coincidence between organizations by recognizing the roles of the members as being an intrinsic ingredient in the organization. Yep.
These three can dovetail, right? So I can engineer with tissue.
Oh yeah.
As
Yeah.
parts.
Absolutely.
Okay.
What matters really is the possession of an autonomous complete boundary.
Okay.
And it doesn't even have to be complete, it can have holes in it.
Yeah, perfect.
Sweat.
Yeah.
Yep.
So this is a terminological clarification. So you mentioned that there's immaterial entities. Is BFO taking like a stance on materialism or non-materialism?
No. When it comes to mental disease, we do hold that every mental disease has to have some kind of physical disorder underneath it. So for disease of the mind, we tend to be focusing on the physical basis. But we don't say that the mind is identical to the brain, nor do we deny that the mind is identical to the brain. So when we say that the person is identical to the human being, that does not have any implications for the question of what the mind is. Yep.
I don't know if this question is going to be allowed, but it's something that I wonder about. So the classes in BFO are universals.
Yep. In order to give the opportunities that scientists need to deal with certain kinds of entities which are not BFO conformant, we also allow defined classes.
Right.
An example would be friend of Neil. So if somebody was doing a scientific study of friends of Neil, then they could introduce into their ontology the defined class friend of Neil.
Right, but the sort of natural classes are.
Well, they don't even have to be natural, providing they're properly defined. You have to give necessary and sufficient conditions.
Okay. So what I'm wondering about, and feel free to just say this is a stupid question, you don't have to answer it, but what is your view about what the ontological status of those universals are? Do they...
The real ones, you mean?
Yeah, the real ones. Are they occurrence? Are they continuance?
Yeah, so fortunately, so BFO does not include the term universal in the ontology. This was a mistake made by Guarino in the early versions of Dolce. He had universals and instances as being top-level terms in the ontology, and that crashed. It didn't work. So you can't ask the question you want to ask in BFO terms. You can ask a meta question. So what do the proponents of BFO think they're talking about when they talk about universals? And I'm a realist about universals. I think the universals are regularities in nature, invariants in nature, if you like, which enable natural science. If there were no invariants in nature, natural science would be impossible. And so I'm a realist in a very strong sense. And that tends to be the impulse behind BFO. But there are people who use BFO who don't care about those kinds of metaphysical questions at all. They just think of BFO as an instrument. So they have an instrumentalist view of universals, which I'm quite happy with. I think that's.
But you couldn't tell me where in the BFO framework universals would fall.
No, the question is it makes me have a slight brain pain. All right? Yeah.
So I want to bother you about possibilities again.
If that were only possible.
Yeah. So if I go home tonight and I'm worried about the possibility of Donald Trump becoming president.
Yeah.
I can kind of buy the idea that what I'm worried about is this disposition that
exactly.
appears in
You're
reality.
worried about that.
Complex.
This is a very clear example in favor of my view.
Yeah.
What you're worried about is all the dispositions of all the people that you see around you,
sure,
who look as if they might want to vote for him.
Here's the problem, though. If I want immediate data about the likelihood of this fact, or I don't know what data would be shaped like such that it would be about the total complex of dispositions.
Okay, I think very many really interesting things are precisely total complexes of dispositions like that. Language, the English language is a total complex of dispositions like that. The Christian faith is a total complex of dispositions like that. The price system is a total complex. The law. You want some more examples? Influenza is a total complex of dispositions. All right. Yep. One last question.
Okay. So in your teaching, you claim that peace, war and peace, is an instance of noble universal.
Yeah.
So should characteristics in novels or movies exist?
Characters?
Yeah, characteristics.
Characters, you mean? Characters?
Yeah, characteristics.
No, characters.
Yeah, they don't exist.
So,
as universals.
Characters in novels are like unicorn. They don't exist. So when you read a novel, you are deliberately reading stuff which you know... Sorry, you're reading stuff which you know is not about anything. Now, War and Peace is a special case, however, because it is about Napoleon and Moscow, but many of the characters in War and Peace are fictional. In fact, the hero is fictional. But Napoleon is in there, and Moscow is in there, and France is in there, and so forth. And the burning of Moscow is in there. So we're going to talk about this when we talk about information artifacts. Information artifacts are always about something, even if it's only about people. So even a fictional work is about people, the universal, or love, or angst, or even if all the characters are fictional, the universals instantiate. I have to be careful here. The universals, which the descriptions of the putative characters are conveying, are existing universals. Otherwise, we wouldn't find the novels interesting. So they're about love and sex and love and death. And all right, that's the end.